Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Listen to these questions as many times as you need until the answers pop into your head. Today we're revising Physics topic 2a.6, a special type of resistor, a thermistor, covering resistance of non-ohmic conductors, how a thermistor works, how temperature sensors work, how thermostats work, and tackling exam questions. The resistance of a non-ohmic conductor. With non-ohmic conductors such as a thermistor, the current, potential difference or PD, and resistance are inversely proportional. What does inversely proportional mean? It's when one variable goes up, the other goes down, or both variables could increase, but one will increase at a faster rate. About a thermistor in sensor circuits. Thermistors are a type of resistor which depends on temperature. Thermistors are used in sensor circuits, and you need to learn how their resistance depends on temperature if it gets too hot or cold. The first is a typical sensor circuit used in hot conditions. As the temperature increases, the resistance of the thermistor decreases, and the output potential difference across the resistor increases. This type of sensor circuit is used in temperature sensors in appliances like air conditioners, fire alarms, and fridges and freezers. When the temperature gets too hot, more power will be supplied to the appliance to trigger it to come on and cool the environment or set a fire alarm off. The second type of sensor is an alternate sensor circuit. In cold conditions, as the temperature decreases, the resistance of the thermistor increases, and the output potential difference across the resistor increases. This type of sensor circuit is used in a thermostat to control a central heating unit and to trigger the boiler to come on to heat a house or building. If the temperature decreases or gets colder, both these circuits use the output potential difference across a resistor or thermistor to power another component, depending on their resistance. What do you need to know for the exams? How the resistance and output potential difference change across a thermistor or resistor, in either a temperature sensor, when the temperature gets hotter, or a thermostat when the temperature gets cooler. How does a thermistor work? The resistance of a thermistor depends on the surrounding temperature which it is able to detect. Thermistors are connected to a sensor circuit where their resistance can be measured. The thermistor in a sensor circuit can be used in a thermostat to turn on or off an air conditioner or heating system, depending on the surrounding temperature. A temperature sensor can be used in a car engine to make sure it isn't overheating. So a typical exam question could be something like this. Give two applications of thermistors. The correct answer would be they are used in thermostats and temperature sensors. Resistance and potential difference of a thermistor in a temperature sensor circuit, covering how a temperature sensor circuit works. An experiment using a temperature sensor circuit. Tackling an exam question 1 and tackling an exam question 2. You need to understand how resistance and potential difference works to be able to answer exam questions. A sensor circuit produces an output PD or potential difference, which changes because of a physical variable like a change in temperature. A sensor circuit consists of a potential divider, which is made using a thermistor and a resistor. We have the input potential difference from the power supply, which flows around the circuit through the thermistor and then the resistor. Because the thermistor and resistor are in series, they share out the input PD potential difference relative to their resistance. Relative to their resistance means the component with more resistance will take a bigger share of the output potential difference. Looking at this sensor circuit, if the resistor has more resistance, then the thermistor will have less resistance. This means the resistor will have more output potential difference, as the temperature sensor detects an increase in temperature when it gets hotter. Temperature sensors are used in appliances like air conditioners, fire alarms, fridges, and freezers. An experiment using a temperature sensor. By just looking at this diagram, how can you tell in this experiment that this is a sensor circuit? It's because there is a resistor and a thermistor connected in the circuit. The thermistor is placed into the water and set to measure the temperature. The water will be heated slowly by the Bunsen burner. A temperature probe and data logger will record the increase in temperature. The reading on the voltmeter will change when the temperature of the water increases. You will need to understand and be able to explain what happens to the resistance, current, and potential difference in a temperature sensor circuit. Quick recap on what we know to help us answer this question. Current, potential difference and resistance of a thermistor, a non-ohmic conductor, are inversely proportional. This means when one variable increases, the other decreases. Remember, in a temperature sensor, the resistor has a higher resistance than the thermistor. So when the thermistor detects an increase in temperature, its resistance decreases. Therefore, the current in the circuit increases, causing a bigger share of the output potential difference across the resistor. Go back over this slide until you fully understand how the resistance, potential difference, and current work. Tackling exam questions on thermistors. Question 1. Explain how a thermistor works in an air conditioning circuit and what happens to the potential difference. An air conditioning unit has a temperature sensor circuit in it, so we know as the temperature in the room increases, the resistance of the thermistor decreases, causing a bigger share of the output potential difference across the resistor, supplying more power to trigger the air conditioning unit to come on, cooling the room down. Go over how the resistance of a thermistor works until you really understand it and can explain what happens to the potential difference, current and resistance of a thermistor in a temperature sensor circuit. What happens once the aircon has cooled the room down? As the temperature in the room decreases or cools down to the set temperature, the resistance of the thermistor increases, causing a fall in output potential difference across the resistor, supplying less power to the air conditioning unit, stopping it from cooling the room down. Tackling exam questions on thermistors. Question 2. Complete the graph to show how the resistance of the thermistor will change as the temperature of the thermistor increases from 10 degrees Celsius to 100 degrees Celsius. Looking at the graph, we're asked to compare resistance in ohms and temperature in degrees Celsius. When answering any question, you need to find out what the question is telling us. It is telling us that the temperature increases from 10 degrees Celsius to 100 degrees Celsius. Mark this information on the graph to show the range of temperature, 10 degrees and 100 degrees. What is the question asking us to do? Complete the graph to show how the resistance changes as the temperature increases from 10 degrees to 100 degrees. To answer this, think back on what you've learnt in this video. We know that when resistance decreases, it gets hotter. So, because resistance is decreasing as the temperature increases, we must draw the line on the graph going down in resistance, going up in temperature. If you understand how the thermistors work, you will have no problem using what you know to find the answer. If you're still unsure on the facts, go over these slides again. Resistance and potential difference of a thermistor in a thermostat, covering how a thermostat sensor circuit works. an experiment using a temperature sensor circuit, and tackling an exam question 3. How a thermostat sensor circuit works. The main thing you need to understand is how the resistance and potential difference work. A sensor circuit produces an output PD or potential difference, which changes because of a physical variable, like a change in temperature. A sensor circuit consists of a potential divider, which is made using a thermistor and a resistor. We have the input potential difference from the power supply, which flows around the circuit through the thermistor and then the resistor. Because the thermistor and resistor are in series, they share out input PD, potential difference, relative to their resistance. Relative to their resistance means the component with more resistance will take a bigger share of the output potential difference. Looking at this alternate sensor circuit, if the thermistor has more resistance and the resistor has less resistance, then the thermistor will have more output potential difference. This means the thermistor can detect a decrease in temperature, that is, when it gets colder. Thermostats are used to trigger the central heating or boiler to come on and heat the radiators in houses or buildings to keep warm. Tackling exam questions on thermistors, question 3. Explain why the potential difference across the thermistor changes as the temperature in the house gets colder. As the temperature in the house decreases, the resistance of the thermistor increases, and the output potential difference across the thermistor increases. This is because the resistance and potential difference are inversely proportional, and for a thermostat this means both variables increase but not at the same rate. So as temperature in the house gets cooler, the potential difference increases because the thermistor's resistance increase. Test how well you know this topic. Listen to these questions and see how fast you can answer them. In a sensor circuit of an air conditioner, explain why the potential difference across a resistor changes when the temperature of the room increases. When the temperature in the room increases or gets hotter, the resistance of the thermistor decreases. Therefore, the current in the circuit increases, causing a bigger share of the potential difference across the resistor, supplying more power to the unit. In a sensor circuit in a thermostat, explain why the potential difference across a thermistor changes when the temperature of the house decreases. When the temperature in the house gets colder, the potential difference increases because the thermistor's resistance increases. Give 2 applications of a thermistor. Thermistors can be used in thermostats and temperature sensors. When heating water, why would the reading of the voltmeter across the resistor change when the temperature of the water increases? When the temperature of the water increases, the resistance of the thermistor decreases. Therefore, the current in the circuit increases, causing a bigger share of the potential difference across the resistor. Great learning if you managed to answer all these questions. If you didn't, easy. Just go over this unit again until the answers just pop into your head. In this video you've learnt about thermistors and how they work in hot and cold conditions. You need to understand how the resistance, potential difference and current work, as you may be asked a question on this topic in the Physics GCSE Paper 1. The key to exam success is learning, consolidation and keeping this topic fresh in your mind. How do you do that? Repetition, repetition, repetition. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching and see you again soon.